In the previous video, I built a Python program that would help guess the possible names of our new baby niece. And while that program kind of concluded and the baby was already born, I thought it'd be fun to add a little bit of extra functionality to that program strictly for academic purposes. If you have not seen that video yet, I recommend that you go watch it. I'll leave a link to it. Otherwise, this video isn't going to make much sense. But part of the conclusion of the last video was that there were a list of names that were viable baby names. However, there were duplicate names within the list. So there were certain names that had the same name, but they were spelled in different ways. I thought this would be a good opportunity to add some more functionality and eliminate any of the duplicate names and return a new list of names that are solely unique names. So this video is actually going to be going more piece by piece through each bit of code. So if you want to code along, this is going to be more tailored to do that. And I'll also leave certain timestamps if you want to jump ahead and just see how it runs itself. I hope you enjoy the video, and hopefully the audio and the visuals are a little bit better in this video than last time. The code was a little bit smaller than I first anticipated, and the initial video, face-to-face video, was a little bit, the sound was really groggy and really fuzzy. So I hope all this gets worked out in this video, and I hope you enjoy. If you like the video, please leave a like and feel free to subscribe for more videos like this in the future. Thanks.
All right, so we'll be going through the logic of comparing the names step by step. I'm hoping that this will make it easier to understand the process of going from logic to functions. I'm also hoping that the font is a little bit easier to read than in the last video. For this problem, we're going to keep things simple, and we're going to determine that if two names only differ on one letter, they will be considered a duplicate name. Obviously, there are examples of names having multiple different letters, but keeping it simple to one letter difference will cover all the duplicate names for this program. Plus, this is meant to be an exercise of solving a simple problem, and if it was needed in the future, we could always make further tweaks. Now, looking at lines 100 and 101, you can see that Candace is spelled two different ways, and I just set the variables S1 and S2 to each one of these strings. And in order to first compare them, I figured that we can use what is called the zip function. A zip function will basically do as what it sounds like, and it will zip through an iterable. So strings are iterable, so it can go through each and every character, and it can return a tuple of each pair that it combines. So that kind of sounds a little vague, so let me show you how that works. I'll create a variable that we'll call compare, and we'll do zip of, and it takes two arguments, so the two things that you want to zip, so S1 and S2. Whoops, can't type. And in order to actually print or use this kind of tuple, you have to actually convert it to a list. And once I print it, it'll make more sense. So let's make a list out of the zip. And we will print compare. So if I were to build this, you'll see down in the console here, here's each tuple. So you can see a pair tuple is a pair of two. And within each tuple, it is all contained within a list. So that's why we had to make a list. And if you look, you'll see how each character is combined together. And here's where the difference lies. You have an A character and an I character. Everything else is exactly the same. So I figured it would be easy if we could create a running count that goes through each one of these, and it will count how many different letters there are. And if there's one different letter overall in the entire name, we can determine that that is a duplicate, and we can store it in a different list altogether. So to do that, let's first create a variable that we'll call, let's just call it different letters. We'll set it equal to 0. And then we will iterate through each one of these tuples in the list. And to iterate through a tuple, in order to use both characters within the tuple, what we can do is going for x comma y, which we'll represent this is X and this is Y. In compare, because compare is the list name itself. If X is not equal to Y, which we'll see in this case right here. Whoops, right here. First, let's just print it out just so we can make sure that we're doing the right thing. And then we will add the count to different letters. So diff letters plus equal 1. Now, what else? Is there anything else I should do before I build it? Let's just build this first. So as you can see on line 109 how we printed out X and Y, it returned to the console A and I right here as we would expect, because this conditional was met if X is not equal to Y. In all these other cases, X is equal to Y except for right here. And so it runs this line of code. And it doesn't show it, but different letters is now equal to 1. So to show, in order to grab that duplicate name, which we can grab either the first or the second name, it doesn't really matter. We can just grab the second name for functionality's sake. I will first create an empty list that we'll call repeat. Well, let's call it repeat names. If I can type. Repeat names equals empty list. And we'll create another if statement. So if the different letters is equal to 1, because remember we're only going to count duplicate names if they're differ by 1 character. We'll take repeat names and then we will append, we'll just say S2, which keep in mind is right here. We'll append S2 to that, and we will just print out repeat names so it'll show up in the console. So if I were to build this, you see that Candace, since all these conditionals were met, Candace will fall into that new list of repeated names. Now, if the zip function is still a little foggy to you, I will instead, let's comment this out, and I will create another variable. Let's just do a list of numbers. Now, if we were to replace the zip with S1 and S2, we'll change S2 to S3. So we'll combine this and this together in 2 tuples. Let's build it. As you can see up here, so the capital C is 0, A, 1, and 2, and so forth. And then, since none of these are equal to each other, it actually prints out each and every one.
All right, so now I'm going to be going through all the logic and turning it into functional code. As you can see on the screen right here, I turned a little bit of what we talked about earlier into 2 separate functions, one called zip names and one called find differences. If you'd like to just skip ahead and not have me listen to me go through each line and explain everything, I'm going to put a timestamp in on the screen right now, but I'm also going to be typing line by line the rest of the logic to tie both the functions together and to hopefully return a list of duplicate names. So if you'll see on line 103, the function zip names takes in 2 arguments. As we were talking about the zip function before, we called them S1 and S2, but to pass in arguments, I figured it'd be better to name them name1 and name2. And it takes a variable called pairs, and it sets it equal to a list, and it would be zip of 1, or zip of name1 and name2. And I forgot, since this is a function, we need to return the pairs. On line 107, on the function called find differences, takes in an argument called pairs, which will take in this pair of tuples, or this list of tuple pairs, I should say, and it first takes a variable called different letters that's equal to 0, and then it goes through the same logic of counting the amount of differences between the tuples. So it goes through x and y, and if x is not equal to y, I'll add 1, and it just returns the total number of differing letters in a word. If you'll recall also, the logic that we used also found and grabbed one of the names, and I'm going to actually be doing that within the program itself. It doesn't need an actual function. Let's start by creating an empty list called repeated names, and we are going to be using what's called a nested for loop, meaning that we want to go through each name comparison to each other only one time. So using a nested for loop, we can do for, it doesn't really matter what we call it, but to help understand, let's call it for a in range, and we want the length of viable names. This is from the program last time. We just created a variable called viable names, and this is just the entire name list that has both the middle character is a D and it's an odd number of characters, but it also has all of the duplicate names that are within it. So we want it to go through that entire list. So we'll call it viable names. And then to make it a nested for loop, we'll say for B in range A from the previous line plus 1 through the length of viable names. So essentially this makes your program a little bit more efficient, and it stops any kind of redundancy of comparing names to each other, the same names to each other multiple times. For name 1, first we're going to go through all the other ones, and then once all the other ones are done, this next will turn to name 2, and then it'll go through 3, 4, 5, 6, 7, and so forth. This might seem a little confusing at first on why I'm typing this, but after I typed up everything, I figured that it actually needed a little bit more functionality. So at first I need to take into account the limitations of the zip pairing and the different starting names. So some of these names, when I first wrote the program, seemed like it thought it was repeating this names even though they had different first letters. Like Edie, E-A-D-I-E, and Sadie, they had them as the same name, in which they very much are not the same name, even though there's only one letter difference between the two. So I figured that we can take into account that the first letter is different between the two, then they're probably not the same name, or a duplicate, I should say. So for each comparison that we're going to be going through, we're going to first say if the length of viable names for A is equal to the length of viable names for B. So if the length of the two names are the same, and if the viable names of A at index 0, meaning the first letter, is equal to viable names at B, type B at spot 0. If those two conditions are met, what we will then do is take a variable called pairs, and we'll say pairs is equal to running the function called zip names at, and it'll compare viable name A with viable name B. So it will run this zip names function up here, and what it will do is it will set that list of tuples, and it'll set it equal to the name pairs. And as you'll recall, on line 107, the argument taken to run the function find differences uses an argument called pairs. So you can probably guess where we're going with this next. We'll say another variable we'll call total diff. It's going to run find differences, that program that counts the amount of differences between the tuples. And it's going to take the argument pairs from the line above, and line 118. And if the total difference is equal to 1, which is what we determined, that if the difference was equal to 1, it will be considered a duplicate name. We will first print out just a little statement so we can understand what two names we're comparing, so that we'll know which two names that the computer program thinks are duplicate names. So if we have any odd edge cases of similar names that are not duplicates, we can determine whether or not there's a problem with our program. We'll just say versus, and then viable names at B. And then what we can do is I'll just copy and paste this last line of code. We will take the second name between the two when it's comparing, and we'll count that one as the repeat name. So it's going to take repeated names that you see on line 114. It's the empty list. It's going to append the second name that's being compared that is considered a duplicate to this list. And so in order to use it at the end, what we can do is I'll just copy and paste this to make it a little bit quicker. We'll first print out a statement that says list of duplicate names, and then it's going to print out the entire list of all the second names in comparison that it thinks are duplicates. So if we were to run this, it looks like I have an error. Let's see. Repeat names is not defined. Oh, it's because I have repeated names. So if I do repeat names up here, hopefully, there we go. All right, so looking down at the console, here is the list of all the possible names given the two criteria from the previous video. And then it goes through it'll print out each verses that it thinks are duplicate names. So Ada versus Addie, only one difference is the last character. Addie versus Andy. Those are kind of two different names, so maybe that could be a little bit of a flaw with this logic. Candace and Candace. India versus Indy. They're close, but yeah, it's not perfect, but I still think for these purposes it kind of does a good explanation into how we can eliminate really close names. Isadora and Isadora. Isadora and Isadora. Good. Jaden versus Jaden, that's obviously good. Lydia, two ways. Lindsay for the three different names, that's good. And then it returns a list of duplicate names. And so now what we can do, I'm going to cut here, but basically I'm going to program this list minus these names to return just a list of unique names. All right, picking up from where we left off, looking at line 126. I created an empty list called unique names, which is going to take the first list that had all the viable names and minus all the repeat names that you can see how we used in line 124. So it first iterates through each of the names in viable names, and if that name that it's currently iterating through is not in the list of repeat names, it's going to append it to a new list called unique names. And I just printed out a little simple statement saying list of unique baby girl names, and then it prints out that entire new list, which should be the condensed versions of, just to recap, it went through all 2,200 and something unique or different girls' names. It only selected the ones that were an odd number of characters, and the middle character was a D. And then it eliminated all the duplicate names within that condensed list to have the final list of names that could be viable baby names, or could be possible baby names, not viable names, since we called the list that earlier. So let's build it. Now this looks a little jumbled, but the important part is right here, because I just printed out everything from earlier. List of unique baby girl names, and it cuts off towards the back end over here, so I'm sorry about that, but looking at everything from my screen, I can tell that you can see there's one Candace, so there's not two different Candaces. There's one Lydia, there's one Lindsay. Remember, all these had repeat names before, so this program, it works for the purposes that we need it to work for, and I think that it overall shows how you have to go from using the logic of how you can understand how certain things can work together to turn them into bite-sized chunks using functions, and then finding ways to call upon those functions to provide a particular task for you. Now, in the future, if there ever becomes an issue where you're running different conditionals, trying to find out different names using different types of criteria, this kind of logic might not work. Like how I mentioned how certain repeat names might have multiple letters that are different. But given that it seems to have worked pretty well for this, I'm going to keep it the way it is. I'm going to link it to my GitHub as well with this increased functionality. So if you want to look at the code itself, or maybe if you're trying to follow along and you can't understand something, you can look at that and refer to it as a guide. I'm going to be adding more definitions to these new functions just so it's a little bit more formal and better tidied up. But if you have any suggestions for new videos, or if you have any criticisms of this kind of work and if you would have done something different, I would like to hear from you. I'm always looking to improve my programming myself, and so if there was a quicker way to do something or a more accurate way to decipher duplicate names, I'd like to hear it. I know there were some libraries that people have made before that can cut down on some of this work, but for this purpose, I didn't really want to be using so much of other people's work as opposed to going through the basics of Python and using my own logic to come to certain conclusions. If you enjoyed the video, I would appreciate a thumbs up, and if you want to see more videos like this or any videos in the future, I'd appreciate a subscription too. That's it for me. I hope you enjoy, and until next time, thanks.